So, Romil, you are preparing for DRDO,
Yes,
and it
ma'am.
is B, and you are prepared with the subject of algorithms. So, let's start your snap. Okay. So, which sorting algorithms have you studied?
Ma'am, I studied quick sort, merge sort, insertion sort, or console. Any one of them, ma'am. You can ask me.
Okay. So, which is the optimal sorting algorithm according to you?
It is a merge sort, ma'am, because it take an order of n log n. In the worst case, big O n log n.
Okay. What is merge sort? How do we sort it?
Ma'am, merge sort is an algorithm, is a sorting algorithm, which divide the all the element in array in the in sub array. I mean, divide the element into divide the all the element in array into elements such that there is only one element in array, such that so that in the end it combine sort the element and then combine the solutions. I mean to say, ma'am, what it does follow the conquer and divide. I mean, divide and conquer technique means first it divide the problem into small problem and find it optimal solutions, and then you use this optimal solution of the sub problem to find the bigger solution of the bigger problem. So, ma'am, this is what it happened, ma'am. In sorting in merge sort, it can be said like that. Merge sort is a sorting algorithm, which first divide the element into smaller number of element in an array, and then it sort the element and then find the find the bigger solution for the bigger element.
So, can you find the recurrence equation for merge sort?
Sorry, ma'am.
What is the recurrence equation for merge sort?
Ma'am, recurrence is, ma'am, I have to write, should I write on paper or like this, should I say, ma'am?
You can say like this first.
Okay, ma'am. Recurrence relation is, ma'am, first, it will be merge sort. It will call a function merge. It will be a merge sort. It call a function merge sort, which will pass the parameter. Suppose age array. It will pass the parameter a, and then before that, ma'am, before calling the function, it will first
I think you
is a
misunderstood the question. I am not asking the algorithm. I am asking recurrence equation.
okay. Recurrence equations. Ma'am, recurrence equation is
Some t of n equals to something.
yes, ma'am. Actually, is yeah. Actually, it's t of n is equal to 2t n by 2 plus order of n. So, t of n by 2 is because of is always divide the element into two halves, and an order of n is because of merging.
Okay. So, how much time does it takes to merge? Can you
Ma-
derive like how time complexity is calculated in the merge sort algorithm?
Ma'am, actually, I have to find the time complexity of the merge sort. Then first I will write that recurrence relation, that is a 2t n by 2 plus order of n, and I've applied the master theorem. Then it will become n log n, ma'am, because according to master theorem, ma'am. And the thing is, ma'am, the time taken to merge is order of n. If
Okay, you told merge sort works on divide and conquer.
yes,
Some
ma'am.
other approaches, do you have any idea which are there?
Ma'am,
It
mean
means
to some other idea, ma'am, I didn't got it. Like, ma'am, sorry.
which all are other techniques other than divide and conquer you can recall?
Ma'am, binary search, ma'am.
Binary search works on?
Sorry, ma'am. That one, binary. What was that? Binary search, yes, ma'am.
It
Is
works on what?
ma'am. Actually, ma'am, it's a divide and conquer technique, ma'am. It divide the what it happened. Suppose there is n element in an array. It divide the element and first go to the middle part. If it doesn't there, then again divide the element and go to the left or right according to.
Okay, what is the time complexity of binary search?
Ma'am, my order of login.
Okay. It will be a login in all the cases, right?
Yes, ma'am.
Best, worst, and
Sorry.
average.
Yes. Yeah, it will be average.
Okay. So, my question was actually, can you recall any other technique other than divide and conquer? Any other approach?
Okay. Ma'am, for the merge sort.
Not much sort. Other than divide and conquer, any other technique we use, like can dynamic programming you
Yeah.
might have heard of.
Yes, ma'am.
So,
But
what
the
is
thing,
dynamic programming?
ma'am, dynamic programming is a technique to solve a problem, a bigger problem by dividing a problem into smaller problem, and then finding the solution of the smaller problem which are overlapping to find the bigger problem, solution of the bigger problem using a optimal solution of the smaller problem. But the difference between divide and conquer and the dynamic is uh, the problem are not overlapped in dynamic in divide and conquer, but in dynamic programming what happens, the problem are overlapping, all the small sub problems are overlapping, so that become a dynamic programming. And while in divide and conquers what will happen is also divide the problem into sub problem, but the sub problems are not overlapping with each other.
Have you heard about greedy algorithms?
Sorry, ma'am.
Have you heard about greedy algorithms?
Yes, ma'am.
So, can you differentiate between greedy and dynamic programming?
Ma'am, in greedy it always look for the minimum, I mean, optimal solution means like always see the minimum or the maximum. It's like that, ma'am. It never go for the it does not go for optimal substructure. I mean, it does not divide the problem into a smaller problem. Uh, so, ma'am, greedy I will look for the optimal solution. Currently, it doesn't look for the it doesn't look for the overall optimal solution. It look for the local optimal solutions. While in dynamic, it look for the global optimal solution. I mean, a solution, optimal solution for the bigger problem. While in greedy, it look always for the optimal solution, which for the sub problem.
Okay. So, can you give an example of greedy and dynamic where dynamic programming is good? It's finding the optimal solution.
Like, ma'am, knapsack problem, ma'am. Knapsack problem, what will happen over there, ma'am? It what will happen always look for the maximum profit. So what will happen over there, ma'am? Divided the problem. I mean, divided the problem into there also in the sub problems. And after dividing it, what the problems are overlapping. Over there also the problem are overlapping in 0, 1 knapsack. And but in fractionals, problems are not the it doesn't. I mean, problems are not overlap. I mean to say, ma'am, in fraction knapsack we use greedy algorithm because it does not always guarantee the optimal solution greedy. Suppose, ma'am, I took a solution, I took a problem. Suppose like there are 3 items. One weight is 1, second item for is 2, and second and third item is 3. A profit is every given is like for first is 10, second for 6, and third is 28. So if I take a profit by weight for each of them, so what had happened? It doesn't guarantee always the best solution. But 0 knapsack using if I while in going 0 knapsack using dynamic programming, it give up best solutions. I mean optimal
What is
solution.
the time complexity in both the cases?
Ma'am, for dynamic it will be mn. Suppose m is a sorry, m is a number of items and w is a weight of the on I mean now capacity of the I mean capacity. The w will be the capacity and m is the number of items, so it will m into w. While in greedy, it become n log n, because first have to sort the element. The n element, they have to sort the element, become n log n. And then after that, have to divide it, then it become plus order of n. And then after that, have to find optimal solution, have to find adjust according to the capacity. Then overall the value of in fraction knapsack, it will be a n log n. While in greedy, it will be MW, just like that, man.
Okay. Can you tell which underlying data structure is fractional knapsack using?
Sorry, man.
Which underlying data structure is fractional knapsack using?
Ma'am, it use array, ma'am. Array.
Okay. So according to you, in array, the complexity will be n log n if we
Yeah.
implement
Yes,
fractional knapsack.
Yes, ma'am.
Okay. And in 0-1 knapsack, which data structure will we be using?
Ma'am, it will be also, ma'am, it will be 2D array, ma'am. Yes, sir.
Okay. So, can you tell what is traveling salesman problem?
Ma'am, traveling salesman problem actually is its objective is to go through each of the vertex once. I mean, objective is to start from source and go to each of the vertex once, and come back to original position, that is the source, and by covering, and the total sum of the distance should be minimum. So the logic is, ma'am, you have to cover each of, right, start from A, have to go each of the vertices and reach the destination D, then come back to the, I mean, not the destination, means suppose A, B, C, D, E is a vertices in a graph. You start from A and have to go to each of the vertices B, C, D, E in such a way, it again return back to A and it should cover the minimum distance. So this is the logic, ma'am.
Okay. And what is the time complexity?
Ma'am, it will be ma'am, I think, ma'am, n into 2 to power, n into 2 to power n.
Okay. Okay, Roman, let's come to the feedback.
Okay,
Okay,
ma'am.
तो कुछ प्लेसेस पे आपने आंसर गलत दिया था, जैसे कि बाइनरी सर्च का बेस्ट केस में ऑर्डर ऑफ 1 कॉम्प्लेक्सिटी होता है.
Okay, ma'am.
ओके, सेकंड क्वेश्चन जो आपने गलत आंसर किया था वो था कि अंडरलाइन डेटा स्ट्रक्चर जो फ्रैक्शनल knapsack यूज कर रहा है वो प्रायोरिटी क्यू होता है.
Okay, ma'am.
ओके, और उसके बाद ये ट्रैवलिंग सेल्समैन का टाइम कॉम्प्लेक्सिटी होता है n स्क्वायर 2 to the power n.
Okay, ma'am.
ठीक है. और एक सजेशन मैं दूंगी कि आप जो एक्सप्लेन कर रहे हो उसको मतलब थोड़ा क्लैरिटी लाओ. जैसे कि मैंने मर्ज सॉर्ट भी पूछा था, आपको पता है चीजें कि क्या होता है, बट द प्रॉब्लम इज कि आप एक्सप्लेन करने में या तो बहुत जल्दबाजी करते हो या मतलब आप एक्सप्लेन नहीं कर पाते हो. पहले क्या होता है कि आप कुछ बताते हो एंड उसके बाद ये होता है कि फिर आप पॉइंट पे आ रहे हो, आपको पता है बट वे ऑफ स्पीकिंग बहुत अच्छा नहीं आ रहा है.
Okay, ma'am.
ठीक है, तो मतलब किसी भी इंटरव्यूअर को क्या है कि आंसर के लिए वेट करना पड़ रहा है. तो
Okay.
अगर आपको प्रॉब्लम हुआ करे, आप छोटा सा एग्जाम्पल लेकर के समझाना स्टार्ट कर दिया करिए.
Okay, ma'am.
तो अगर आप डीआरडीओ के लिए जा रहे हो, मोस्ट प्रोबेबली एक वर्चुअल, आई थिंक वर्चुअल बोर्ड टाइप का आपको मिलता है, आपको मिलेगा वहां पे, आप लिख सकते हो, आप लिख के एक्सप्लेन कर सकते हो. आप
Okay.
4-5 एलिमेंट्स दे करके मर्ज सॉर्ट एक्सप्लेन कर दीजिएगा.
Okay, ma'am.
ठीक है.
Okay, ma'am.
अगर आपको एक्सप्लेन वर्ड्स में एक्सप्लेन करने में प्रॉब्लम हो रही है तो आप इस तरह से भी एक्सप्लेन कर सकते
Okay, ma'am.
हो. ओके, और बाकी और अच्छे से सब्जेक्ट को रिवाइज करिए,
Okay, ma'am.
छोटी छोटी गलतियों की पॉसिबिलिटी ना हो.
Okay, ma'am. Sure, ma'am.